Welcome to Science in Everyday Life. This is General Science 11, Term on Physics, and in this lesson, we'll explore one of the most practical and exciting topic in physics, the physics of fluids. And to make learning easier, this lesson has been divided into three episodes. Episode 1, What are fluids and understanding pressure. Episode 2, Pascal's principle and hydraulic systems. Episode 3 will be Archimedes' principle and buoyancy. And by the end of this series, you'll understand why ships float, how hydraulic systems lift incredibly heavy objects, and why fluid physics plays an essential role in medicine, engineering, transportation, and many other fields. So, let's start. Our lesson today is called The Physics of Fluids. Well, you might probably think of water whenever you hear the word fluid, but in physics, fluids include both liquids and gases, mainly because both of them can actually flow. And every time you drink water, inflate a balloon, or simply breathe, you're actually interacting with fluids. And understanding how fluids behave helps us understand and explain many natural phenomena, as well as technologies that we encounter every day. From weather systems to blood circulation to hydraulic machines, fluid physics is everywhere. So let's begin with an important question. How do fluid properties and principles explain everyday phenomena and enable technologies? Take a moment to think about it. As we go through today's lesson, keep this question in mind because by the end of this episode, you'll be able to understand and answer it using real life examples. So, for today's learning objectives, first is to describe what fluids are. Second, identify different properties of fluid. Third will be explain the concept of pressure. And lastly, apply the pressure formula to solve simple problems. These learning objectives will help build a strong foundation before we explore Pascal's principle and Archimedes' principle in the next episodes. So imagine holding a plastic bottle completely filled with water. Now try to squeeze it. What do you think will happen? Well, basically, the bottle would change its shape, but the water inside will barely compress. And why do you think that happens? Well, pause the video for a few seconds and think about your answer, because this simple observation gives us our first clue about the unique properties of fluid. So, before we continue, make sure to review a few concepts that you've learned before. Can you still remember the three states of matter? How particles arrange in solids, liquids, and gases? What is force? What is pressure? And how do simple machines make work easier? These concepts will help us understand today's lesson because fluid physics is built upon these fundamental ideas. All right, so now let's talk about fluids. What exactly is a fluid? By definition, a fluid is any substance that can flow and take the shape of its container. Fluids include liquids and gases. Liquid have a fixed volume but no fixed shape. They take the shape of their container, while gases have neither a fixed shape nor a fixed volume. Instead, they expand to fill the entire container. And although they behave differently, both liquids and gases are considered fluids mainly because they can flow. So, fluids have several important properties. The first is incompressibility. Most liquids do not compress easily even when pressure is applied. The second property is viscosity. Viscosity refers to a fluid's resistance to flow. For example, honey flows much more slower than water, mainly because it has a higher viscosity. Another important property is density, and density tells us how much mass is contained in a certain volume. And finally, we have surface tension. Surface tension allows insect like water striders to walk on water and causes water droplets to form into nearly perfect spheres. So let's compare liquids and gases. Liquids have a definite volume, while gases do not. Liquids are nearly incompressible, while gases can be compressed much more easily. The particles in liquid stays relatively close together, while the particles in gases are spread apart or spread far apart and much more or move much more freely. Despite these differences, again, both are classified as fluid because they can flow. So, why do fluids flow? The answer lies in their particles. Particles are always moving. They constantly collide with one another and with the walls of their container. And these collisions create pressure. When pressure increases, particles move faster. As particle speed increases, pressure usually increases as well. This microscopic motion explains many of the behavior that we observe in fluids. So, fluids are everywhere around us. Waters flow through rivers and oceans. Air surrounds our planet and allows us to breathe. Oil lubricates engines. And blood transports oxygen and nutrients throughout our bodies. These examples remind us that fluids are essential for life and for many technologies we use every day. So now let's move to another important concept in fluid physics: pressure. Pressure is the amount of force applied over a given area. If you apply a greater force, the pressure increases. If you apply the same force over a small area, the pressure still increases or also increases. This is why a sharp knife cuts more easily than a dull knife. The force may be similar, but the contact area is much smaller. The SI unit of pressure is the Pascal, symbolized as PA. 1 Pascal is equal to 1 Newton of force applied over 1 square meter. Pressure can also be measured using other units depending on the situation, but in physics, the Pascal is the standard unit we'll use. For the pressure formula, the formula for pressure is pressure equals force divided by area, or simply P equals F divided by A, where P is pressure, F is force, and A is area. This formula helps us calculate the amount of pressure exerted on a surface. So let's see what happens when force changes. If the area remains the same, increasing the force increases the pressure. Decreasing the force decreases the pressure. This means pressure is directly proportional to force. The greater the force, the greater the pressure. So let's keep the force constant. What happens if the area becomes smaller? Well, pressure increases. This explains why high-heeled shoes sink into soft ground more easily than flat shoes. Although both support the same person's weight, the high heel concentrates the force over a much smaller area. So let's solve a sample problem together. A force of 500 newtons is applied over an area of 0.25 square meters. Using the formula P equals F divided by A, pressure equals 500 divided by 0.25, the answer is going to be 2000 pascals. Always remember to include the correct unit in your final answer. So now it's your turn. Pause the video and solve the practice problem shown on your screen. Take your time, and when you're finished, resume the video and compare your answer with the solutions. Remember, practice is one of the best ways to master physics. And so, pressure is all around us. Your your car tires use air pressure to support the vehicle. Your heart pumps blood through your body by creating pressure. And even weather patterns are influenced by changes in the atmospheric pressure. These examples show that pressure isn't just a concept in a textbook. It's actually something we experience every single day. So, congratulations, you've actually completed episode 1 of our Physics of Fluids series. Today, you've learned what fluids are, explored their unique properties, and discover how pressure help explains many everyday phenomena. In episode 2, We'll explore Pascal's principle and discover how hydraulic systems are used in hydraulic brakes, lifts, construction equipments, and many other real-world applications. If you enjoyed this lesson, don't forget to like, subscribe, and turn on your notification bell so you won't miss the next episode. Thank you for watching, and remember, science isn't just something we study in school, it's something we experience every single day. See you in episode 2. Bye!